Good afternoon, ladies and gentlemen. So, this particular video is talking a little bit about what happens when you start to make circuits a little more complicated than just a battery and a light bulb. Okay, and specifically, we're going to talk about the two different ways you can set up a circuit, which are referred to as series circuits and parallel circuits. All right, now this is going to be the first of two videos. The first video is going to talk about series circuits, some of the rules they have to follow, and the second video for this we'll talk about parallel circuits. Okay, so to start with, all right, regardless of if a circuit is in series or in parallel, all right, it allows something to flow through the circuit. Okay, and for us, the most important thing that a circuit does is it allows electrons, or in this case, we're going to refer to it as current. So electrons slash current to flow. All right, now what we're going to find out is that actually current doesn't necessarily have to be electrons. It's just the way that electricity works it is. But in theory, you could actually push protons through, depending on how you set it up, not to make things too crazy. But for our case, in all these cases for a circuit, current is the thing that is flowing. All right. Now, a series circuit is, you'll notice something that is drawn off to the right. This is a series circuit. Okay. And every series circuit has the same thing going on. All right. And that is that there's only one path for the current to flow through. So in a series circuit, we can just define it as the circuit only has one path for current to flow through. Okay, and it doesn't matter how many things I put in this circuit. In this case, the circuit to the right has 3 resistors. All right, and we're going to talk about not in the next video, but the video after that, you're going to talk about what these symbols actually mean. But I could put as many resistors as I wanted to in a line, but as long as there's only one line through the whole circuit that the current can travel through, that's a series circuit. All right. So series circuits are pretty easy to see. If it looks like there's just basically one pathway for the current to go through, that's in series. Okay. And usually series circuits are the most basic circuit that we talk about, and usually it's the ones we always start with because it's just easy to look at everything in one circle. Now, as the electrons move through a series circuit, they're going to lose some energy, all right? And they're going to have to because it's going to take them work to get through certain parts of the circuit. Now, we talked about this previously, but in the circuits that we talk about, wires are considered to have 0 resistance. We consider them to be ideal, all right? In reality, wires do have some resistance, okay? But the things that really have more resistance are going to be either resistors or light bulbs, all right? Now, if you think about it like this, I asked the question, where do electrons lose more energy? Really in the wire or in the light bulb, all right? If something has a high resistance, it means that it's going to resist the movement of an electron, which means that electron is going to have to use a lot of energy to get itself through that particular thing, all right? So what we find out in circuits is that electrons are given energy through the battery, and they move through the circuit, and that energy is turned into things that we use when the electron pushes itself through whatever's resisting it. All right. The easiest way for us to visualize this is a light bulb. All right. Light bulbs usually have high resistance, which means the electron has to spend a lot of energy going through that light bulb filament. And what that does is that energy turns into heat usually, which eventually will turn into light. All right. So in this case, we're going to talk about where the electrons use more energy, the areas high resistance, which in this case is going to be the light bulb. All right, and this is what happens with a lot of things that use energy in a circuit. It could be a heating coil. All right, the way they heat them up is literally the electrons are dropping off energy in that heating coil, and that is what's heating it up. All right. Now, if we had our circuit, let's open up our circuit construction kit, and of course I don't have it readily available, but I will. All right. So I'll link this in the Google Doc, don't worry. But going back to our circuit construction kit. All right. If you have 2 light bulbs with identical resistance, all right, so basically 2 identical light bulbs, I want you to set it up so that you have a circuit where there's only 1 light bulb in series with the battery, and then set it up so the circuit has 2 light bulbs in series with the battery. All right. So I want you to take a sec, go in the circuit construction kit, make 2 circuits. Literally pick up 2 batteries. Make one where there's only 1 light bulb in it, another one where there's 2 light bulbs in it, and it's a series circuit. All right, so pause this video, Take a couple minutes, however much time you need, and then come back. All right, so for us, looking at this, if I just I start with just the first one where I only have one light bulb, right? So I'm just going to hook it up. This one over here is going to be one light bulb. I hook it up. All right. You'll notice it's symbolizing, it's probably it has some brightness. Okay. And that's what those little yellow lines mean. Now, if I set it up that there are now 2 light bulbs in series, let's see what happens. Okay. Now, as I'm doing this, we just kind of look at what's going on here. The light bulbs are utilizing electricity because the electrons are having to drop off energy to move through this filament. Usually the filament in a light bulb has a different resistance, and it makes it much more difficult for electrons to push through, so they have to drop off a lot of energy. All right. Now you'll notice if I compare this one, I now have 2 light bulbs in series. You'll notice, for one, the electrons are not moving as quickly, all right, compared to this one, which means the current is actually less here because the electrons aren't flowing as quickly, not as much charge going by a certain point in a certain time. And the brightness has actually dropped, all right? And that's one of the fundamental things about a series circuit. If I put multiple things in series, what happens is basically less energy is dropped off at each light bulb. And we're going to talk about in a second why that is, because there's a very specific rule that electrons have to follow when they're going through a series. All right, and if I added 3 light bulbs or 4 light bulbs, we'd see that the brightness would keep getting smaller. All right, so once again, how do they compare? The 2 light bulbs were less bright than 1 light bulb. Now, the reason this happens is because there are specific rules that govern how circuits work, and specifically how electrons move in a circuit. All right. Now, in series, there's 2 very specific rules that happen. The first rule we're going to focus on is referred to as the loop rule. Okay. And what that is that if I look at a circuit, all right, and I start anywhere in the circuit, and I basically trace the path of the circuit. All right. If I make a loop, a full loop, when I trace that out, everything that is on that loop will have the same current going through it. Okay, and what that means is that if I trace the loop right here, that means that the amount of current going through this part of the wire is the same as the amount of current going through the light bulb, is the same as the amount of current going through this part of the wire. And if I trace this path, all right, it's a bit more complicated only because there's more things to go through, but the amount of current going through this wire is the same as the amount of current going through this light bulb, which is the same as the amount of current going through this light bulb, which is the same as the amount of current going through this wire. All right? So what the loop rule specifically says is basically, in one loop, the current is the same at all points. And once again, one loop is literally you are tracing out the wire until you make a path back to where you started. All right? So that's an important rule for series circuits, because what it means is that at any point in that circuit, the amount of current going through it is the same, regardless. I'm going to find out why that matters when we talk about what happens when circuits get a bit more complicated. All right. Now, the other piece of this is the voltage drop. Now, what that means is that when I start with my electron and I push it through the battery, I basically give it a voltage of 9 volts. Now, we've already talked about this, but when the electron gets to the end, if there's nothing on the wires except wires themselves, so basically I get rid of the light bulb, it sets the battery on fire. And the reason is because in order for a circuit to work successfully, the electron has to lose that voltage before it gets back to the battery. It has to drop back down. Okay? And what that means is that when you go through a series circuit, looking at this, you have to drop down to the level of 0 by the time you get through all the resistors or light bulbs. Okay? So, in this case, excuse me, going back to our waterfall example, what it means is that if I lift up my electron or my water to the top of the waterfall, by the time it gets to the end of the circuit or the end of whatever's going on, it has to have fallen all the way back down the waterfall and gotten back to 0. Okay? If it doesn't do that, then what happens is you start to get a short circuit, and the electrons gain more and more and more energy, and eventually they just kind of run away and they catch things on fire because they have too much energy. All right. So what that means is we have something that's referred to as a voltage drop. Okay. So in series, the voltage drop is how much voltage you lose when you go through something. So it's how much voltage you lose when you go through a resistor. Now, what that means is that as you go through resistors or light bulbs, whatever, in series, you lose some voltage. But that all has to add up and kind of adjust so that it equals whatever the voltage of the battery was when all is said and done. So if we look back at our kind of example here in the circuit construction kit, for this one, the battery, I believe, is about, oh, it's 9 volts. Cool. This is a 9-volt battery. That means by the time the electron gets through the light bulb, because that's really the only thing providing resistance, it has to have dropped all 9 volts. All right? Basically, it's given up its energy, which means in this light bulb, the voltage drop is actually 9 volts. All right? But if I go to this setup, and now I have the 9-volt battery here, because there are now 2 light bulbs I have to go through before I get back to the end of all this, I can't drop all 9 volts here. So instead, what I do is I drop 4.5 volts here and 4.5 volts here. And combined, the total voltage drop of those two things will add up to equal 9 volts, which is what it needs to be when it gets back to the battery. All right? But that's referred to as a voltage drop. And basically, we're going to find out is governed by how much current's going through the light bulb or the resistor, and what the resistance of that object is as well. All right. So once again, voltage drop, it's how much voltage you lose when going through a resistor. If we're looking at our example circuit up here, if I added up the voltage drops of all 3 of these things, they would all add up to equal 9 volts because it has to get back down to to 0 when all is said and done. All right. Now, at this point, we're going to pause for a second. Just kind of take a minute, just kind of think about it. If you want to look up other stuff too while I'm going over this, because this voltage drop loop rule, there's tons of stuff online about it. It can be kind of weird. I don't necessarily do a great job explaining it through this video. So take a second, just kind of pause. And then I believe I'm going to start the next video. So I'm going to cut this off and we'll start talking about resistance in series. So this is where we're going to end this first video. All right. So move on to the second one and I'll see you there.